wear masks.
Yeah.
I'll let you do that.
What?
I'll let you do that.
Yeah. Okay. Good morning, everyone. Welcome to 6-Man. Do you have your audio? Just a reminder that this session is being recorded. So please be mindful about what you're saying, as usual. This is Notewell. I hope it's not the first time you see it. To be honest, not sure people can read it, but you can download slides and look at it. So, first of all, just a reminder, please wear masks all the time unless you're actively speaking or eating. People who are in the room and would like to join the queue to ask questions, please use the on-site tool using your phone. It does help chairs to manage the queue. It's much easier to manage one virtual queue than trying to track who was in the queue first. So if you are using full client in the room or remote, please keep your video and audio turned off until you actually start presenting or asking questions. That's probably it for the useful tips for the meeting. We obviously have a chat room, which will be monitoring during the session. And by the way, if you say anything in the chat room and you would like us to relay this and the mic, please make it clear. We'll be looking at the chat, but it's not always clear for the chairs if you'd like your question or comment to be relayed. So agenda, we have pretty busy agenda today. We have 4 working group drafts, which you can see on the screen. We have 2 individual drafts, and time permitting, we might have a pretty short announcement about generalized IP tunnels, about side meeting, which happened. Any last minute agenda bashing, comments, suggestions? 3, 2, 1, sold. So since the last meeting, what happened? RFC 9343 has been published. Great, congratulations to authors. We have one document which is currently with ISG. I don't know, Eric, would you like to comment on this? Because I think you have the most up-to-date information.
Yeah, this document came to telechat and it had some discusses. So we had a meeting yesterday morning with one of the discuss holders and some reviewers. There's some audio feedback. That's interesting. It seems like, so we explained some of the background to some of the reviewers who had some issues. We got some more feedback on what browser implementers in particular are concerned about. We requested a W3C review, but it seems like what I did not do was request a review from WhatWG. So that's actually what's going to happen next. There were some other proposed ways to move forward, but I don't know that we need to worry about them until we have some kind of a WhatWG review first. I think one of the proposals was to change this document status to experimental, but that means we'd be updating a proposed standard with experimental, which could be done with an IESG announcement write-up. Another proposal was to revisit changing the syntax, but I don't think we should do that until we know that there's some kind of a path forward, because otherwise it's a bit like bring me a rock, no, a different rock. So that's essentially where that's at the moment. Any questions?
Yeah.
Thank you.
Thank you, Eric. So another draft which we still trying to advance is seed draft. Yeah, so I guess Suresh is ready to give us a last update because yeah, it was we were talking to Spring group about that, but between meetings during to some miscommunications, we haven't made so much of progress until this week.
Yeah, thank you, Jen. Thanks for following up on this. So this is Suresh Krishnan. So I think the current working plan is to take out the issues from the draft and put it into a issue tracker in Spring for the CSET draft. And then like the editor, like, you know, Darren is in the room if he wants to comment, like to kind of pick up the things and see the edits. I think Bob's point was he wanted to see the edits in the draft and kind of like, you know, follow up on that on the spring draft. But I think like, you know, it should clear the site from the 6-man side as long as like Eric kind of keeps a handle on the spring edits getting made. That's it, right? Like, so there's no formal like linkage of this thing, but kind of make sure that the edits are there before this goes into the RSC at Q at some point.
Yes, I was also thinking that our draft should have a normative reference to the other draft so that they get published at the same time.
Okay, sounds good. Thank you. Thanks, Bob.
Okay, thank you. So, as I said, we have 5 working group documents. 4 of them will be discussed today. And just a reminder, I think we mentioned it last time in London. So we sometimes receive a lot of drafts from other working group when other working group are trying to use IPv6, so they might require some protocol development, like new bits in the header, new options mostly, and so on. So what we're trying to do to optimize the workflow is 6-man would prefer to work on drafts related to other working groups after that working group confirmed that there is sufficient interest. What we mean is draft in the working group being adopted or chairs communicated that they believe it's in scope and of interest for the working group. So please, if like you have some drafts for 6-man to review, please make sure that the related working group or area has expressed sufficient interest. So I think that's it. Bob, Uli, any comments or any comments from the room? Okay. Okay, in this case, I guess we can move to the first presentation, which is VTI and IPv6 extension header. Okay, I'm sharing the slides. Hold on.
Okay. Morning, everyone. This is Jadon from Huawei. I'm going to give an update about the draft on the carrying VTN information in the IPv6 extension header. Okay, next slide. Thank you. Okay, a little bit recap about the background of this work. This document introduced a new hop-by-hop option, which can be used to carry the VTN information in the IPv6 packets, so that it can be used by the transit nodes to determine the VTN a packet belongs to, and then the VTN-specific packet processing or forwarding behaviors can be performed. When we introduce the term VTN, actually we mean it is something in contrast to the VPN, which is in the overlay. Now the VTN refers to a virtual transport or virtual underlay network. And the basic semantics of this term is it represents a subset of the network resources allocated in the underlay network. But this semantic of the VTN may cover other attributes of the virtual underlay network if it is use cases or if there's interest to extend it for other use cases or applications. And we have seen there are interests in the working group to generalize this VTN option for some other related functions. And so this recent revision introduces the mechanisms to facilitate the future extensions. Here shows the update of this encoding of the VTN option. The only change to this encoding is we introduce a new field called context type, CT, which is to indicate the semantics and the length of the VTN ID. And we plan to allocate a default or the one specific type for the use case described in this document, which is to use this VTN ID to represent the resource ID. With this encoding, actually we take the data plane processing overhead and the complexity into the consideration. You can see that the encoding has been stable for the whole option, and we just need to use the city type to indicate the length and the semantics. And for each specific city type, the length of the VTN ID is also fixed, so it will be very helpful for the hardware to process it in the fast pass. Okay, next slide, please. I think in the previous version of the draft, we have been introducing some considerations about how to generalize the VTN semantics. Here we also want to go through it and give our understanding about this point. In our understanding, the VTN or VTN ID can refers to a group of the network-wide attributes which are maintained on the network nodes involved in the VTN. For example, we can use this VTN ID to represent the network resource attribute of on the participated network nodes. So it is, can be used as a resource ID. And in other use cases, it may also be used to identify the logical topology a packet belongs to, and it may be used to identify a set of network actions to be executed on a set of network nodes. And although we think the generalization is something really useful and to help to make efficient usage of this option ID values, we think it is also important to understand the boundary of the generalization. For the VTN context, it would be some attributes of the network-wide rather than the node-specific. So it will also be provide a network-wide consistent behavior of related to some specific function or the attributes. And if we want to introduce other type of functions or attributes, maybe it is not a good practice to put everything else into this the same hop-by-hop option. In that case, we will make this option itself too complex to implement and deploy. So we think some reasonable generalization with this hop-by-hop option will be really useful and practical for the implementation. Okay, next slide. Okay, in this draft, we described the processing of the VTN as a resource, VTN ID as a resource ID. On the ingress node, it can encapsulate an outer IPv6 header with a hop-by-hop header, which include the VTN option. And the transit node will use both the destination address and the VTN resource ID to determine the next hop and the set of resources for the packet processing. Then on the egress node, it will decapsulate the outer IPv6 header and the hop-by-hop header, which include this option. For the processing of the VTN option with other context types, that will need to be specified in the separate documents, but out of scope for this one. Okay, next slide. In this document, we also give some operational considerations, mostly related to the operational consideration for the hop-by-hop header. In order to make this option useful and not cause trouble to the network, the operators need to make sure that all the nodes involved in the VTN can either process the hop-by-hop header in the fast pass, or they can ignore the hop-by-hop header, so the packet will never be dropped due to the hop-by-hop header. One approach we proposed as a recommendation in the draft is we can put all the network nodes which support this processing of the hop-by-hop header and the option in a logical topology, so that we can constrain the packet forwarding only in that topology. So we will never go to a network node which does not support this. At the same time, we know that the hop-by-hop processing draft specifies the modified procedure for the processing of the hop-by-hop header. And in that case, for network nodes which comply to that document, they could forward the packet with hop-by-hop header normally. Okay.
Sorry, Warren, you're in the queue. Do you want to ask clarifying questions, or you just joined proactively for questions after
joined
presentation?
on the line.
What? Sorry, can you say it again, please? Okay. Okay. Okay.
Okay, we have last page. Okay, for the next steps, I think in this our understanding is maybe it is useful to use this document as a base of the VTN option specification so that we can provide a stable basic encoding for this option format and also make it ready for the point allocation. At the same time, we can create a registry for the VTN context types in this document. For the other extensions to this VTN semantics, they will need to be specified in the separate documents. Then with this, we can continue to collect the feedbacks from the working group on this document and try to move this forward to the working group last call. Okay.
Okay. Questions? Okay, Warren.
So yeah, I'm just trying to sort of understand how this work relates to the APN stuff, like how much it's being driven by APN work versus how much it's being driven by network slicing. The APN scope and gap analysis document talks specifically about this, and the T stuff talks about it in terms of network slicing, and I wasn't sure sort of where the expected use case is or driver is.
Yeah, in my understanding, the purpose of this document was to solve the network slicing case in T's, and with the discussion in the working group, we have make this option also generic to some extent to cover other attributes related to a virtual network, virtual underlay network. But that, as I mentioned, that the generalization need to be bounded to attributes related to a virtual network, which is means that the attribute is a network-wide attribute, and maybe like the topologies, the functions related to virtual network can be introduced in the future. For the topic on APN, actually, I'm not sure that whether this can be an option for the APN use case, and that, as I mentioned here, if it is, it will be specified in a separate document.
Okay, Tom.
Can't hear you. Can't hear you.
Tom, you're muted. We don't have audio from you.
How about now?
Oh, much better, thank you.
Hello?
Yeah, we can hear you.
Hello?
Yes, we can hear you.
Please
Okay.
go ahead.
Okay, I guess Tom, can you hear us? Not here. Okay, maybe we can move to Adrian question meantime, while Tom is trying to sort his audio.
Thank you, Adrian Farrell. To Warren's point, I spend a lot of time in the routing area, especially with network slicing. I think that the difference between this and APN is the intent of the information that's being carried. So here, this is, if you like, an operational marker from the operational side, saying this is how we cluster our network resources and then how we indicate we're using them, whereas APN is talking about marking packets according to the needs that the application has of the network. They're both talking about an option being to use a hop-by-hop option. And I think what I hear G saying is that there's, it's possible to generalize and put all of the information in one hop-by-hop option, but that might not be a wise idea because as things extend and get more complicated, it will get harder to implement and process.
Okay, Tom, can you hear us? Can you say something?
Can you hear me now?
Yes, we do hear you.
So my question was, for the topology to solve the extension header not being process problem, is there a motivation for that was seen in real world deployment, or is this just a hypothetical solution?
I'm not sure I get all of your question. I think you're asking about how to realize the logical topology constraint. Is that the question?
You had two. One of those was to use the hop-by-hop processing drafts, recommendations from that. But the other one looked like limiting a topology to only nodes that can process hop-by-hop options. I'm wondering for that second one, what's the motivation? Why do you think we might need that?
Yeah, I get a point on this time. So I think for the operational considerations, we proposed for different stages, like for a network with some legacy nodes, which may not fully support the hop-by-hop processing procedures, the updated one, maybe a safe approach is to build a virtual topology so that the nodes which does not support it can be excluded from this path computation and the forwarding. But if we have a network which the operator is sure that all these nodes can support the hop-by-hop processing, we can simply use the mechanism in that draft.
Basic point is in terms of we probably want to solve the general problem instead of a use case specific problem.
Awesome. Maybe not get the full question.
Okay, shall we probably take this to the list?
Yeah, maybe.
Yeah. So Tom, if you don't mind, maybe I can suggest you drop an email on the list so we can have this discussion, have time for it. So, Louis, please.
Yeah, Louis Chen from Juniper Networks. I think the question is, since you add additional hop-by-hop headers, have you evaluating what's the impact to the forwarding plane?
Yeah, I think it has been evaluated. That's why we need to have a relatively simple format and the stable size for the length. So for each specific context type.
The question actually is about what is the performance impact with the additional headers?
Yeah, it can be done in the forwarding path. I think the impact is affordable, but I don't have the details on this meeting.
I mean, do you have any reports on that kind of performance hit?
Sorry?
In terms of the, figures, what's the performance hit when you implement in this way and affecting the forwarding plane compared to normal cases?
Yeah, I think maybe this can be further discussed after the meeting.
Yes, I think I would like to see some statistics or some real testing figures that will help us to understand.
That's fine.
Okay, Shopping.
Hi, this is to Warren's comments on APN and clarifications to agents' response to that. And currently, the information APN is thinking to carry is nothing related with the application and its needs. So everything starts as the network edge. So currently, at the network edge devices, there are some information like VPN information, access interface information. So those information are associated with the packets, but they are somehow lost when the packet is entering into the network. So APN is trying to figure out how to somehow continuously carry this information in some reasonable format, and to continuously having this fine granularity information within the network, and based on those information to provide some fine granular network services. So that is my clarifications. Thank you.
Okay, I'll close the queue after.
Hopefully it's okay to add myself at the last minute again. I just want to reiterate a comment I think I made yesterday in the NTD office hours. I think taking inspiration from 2890, the GRE key text, where it basically says, you know, a whole bunch of things are out of scope, and this is just an identifier for the nodes to decide what they want to do. That the behavior that they execute is not specified by the document. Something like that might be.
Yeah,
That would
we
be
can,
sufficiently general.
yeah, we can take a look at the text and see whether we can make some use of the similar text in the description. Okay.
Okay, thank you very much. We're just on time. So Fernando is the next. Start sharing the slides.
Hi there. Can you hear me?
Yes, Fernanda, do you want to present, or do you want me to control the slides?
Can you do it from there?
Yes.
Awesome. Perfect.
Okay. Yeah, hold on. Not so fast.
Perfect. So hi all, I'm Fernanda Gont. I will be presenting the document Improving the Robustness of Stateless Address Auto Configuration to Flash Renumbering Events. Next slide. So essentially, this is a document on a topic that we have been working for a while now. On this topic, we ended up, working on different paths. On the one hand, we work on a problem statement document that was pursued in the V6Ops working group, and it was published by us, RFC 8978. That's the problem statement for Slack flash renumbering. Then we also did another document on the V6Ops working group, RFC 9096, with recommendations for customer edge routers, which ended up updating RFC 7084. And this document that we are discussing today is essentially, or aims to be like a specification update, such that, we can improve the state of affairs at the protocol level, so to speak. So we have been working on this topic and on this document in particular, for a while now, with, I would say, a lot of the work being done already, probably. Next slide. So if you haven't been, following the progress of this document closely, so essentially we started with an individual contribution, and what we were doing over time was like, grab pieces from the original document, the individual contribution, and discussing that each piece on the mailing list and on different IETF meetings, and moving each one piece at a time, obviously considering comments from from the working group, both on the meetings and on the mailing list. So the last piece that we needed to incorporate was a mechanism to essentially try to detect
or infer stale information and phase out that stale information. This document evolved from the original this algorithm, sorry, evolved from the the original algorithm that we had in the individual submission, and I believe that we have greatly simplified the algorithm in question. Next slide. So this is kind of like the the timeline of the way in which the the algorithm works, but actually the concept is like even simpler than this diagram, and the idea is super simple. The idea is that as you receive route advertisement messages, you will essentially record which piece of information was advertised by which local router. Okay. And the idea is that if eventually you receive an array and that array is missing information that had been previously advertised by the same router, then that's probably an indication that the information, the configuration information has changed. So what you want to do, obviously, in order to cope with possible packet loss and so on, is to just poll that local router with a unicast router solicitation. And based on the response that you get, if the corresponding router advertisement refreshes the information, then information is current. There's nothing that you need to do. You keep all the information business as usual. But on the other hand, if when you poll the local router with a router solicitation, actually even in the response, you still get the missing information, or you still miss the information that that router had previously advertised, then you consider that the information has become stale, and you simply disassociate that information with the advertising router. Obviously, you need to keep in mind that there's like in the case of multi-prefix, multi-router environments, essentially there's an RFC but by Brian Carpenter and Fred Baker. I don't remember the RFC number off the top of my head, but it essentially already suggests that you should do that, like remember which piece of information has been advertised by which local router. So if you look at this timeline, essentially you receive an RA, and what we want to do with that piece that you see in violet or whatever that color is called, we will wait for a couple of seconds. Obviously, the specific values is in the draft, and this is just to cope with at least the theoretical case that we haven't seen in in the real world, but the theoretical case where a local router might split the configuration information into multiple packets. So rather than reacting to the first array, we want to wait for a couple of seconds, because at least in theory, the local router might split the configuration information into multiple packets. So after this array wait timeout value, like after you have waited for say 3 seconds, then what you do is you check whether there is any information that this same router had previously advertised, but is not in this last batch of information that was advertised. That is, like this router was advertising something that now it looks like it's not advertising anymore. So then we wait for random period of time. I mean, this doesn't really change the concept at all. This piece in the middle in orange or whatever that color is just to avoid like multiple local hosts to get synchronized at the same, and send approve at the same moment. So that's the only thing that thing is doing. And then when we get into the yellow part of this, what we do is we just send a unicast router solicitation, and we wait for some period of time, a few seconds, to wait for the possible responses, which would be this RS probe timeout part, like the interface between the yellow part and the red part. So when you get to that part, essentially you have two different possibilities. Option one is that actually the information is still current, so all of the information has been refreshed and there's nothing to discard, business as usual. Or there's option two, that maybe when you, so there was missing information, meaning configuration information has changed, and the information was missing in the original array, but it's also missing now that you have sent a unicast router solicitation probe to the local router. If that is the case, so the information is still missing, what you want to do is disassociate that piece of information with this advertising router. When I'm saying, disassociate with this advertising router is because if there were like multiple routers on the local network segment advertising the same information, you just don't want to remove the whole information. You're just saying, okay, this router is not advertising that information anymore, so the fate of that information will depend on whether other routers are advertising that information or not. If other systems are advertising it, then the information stays there. But if there's no other router advertising this information, then you should phase that information out. Next slide. So this is the algorithm in pseudocode as as in the current draft. Essentially, what you have in in this slide is the event when an RA is received. Essentially, for every piece of information, what you do is you record the current timestamp. Meaning, you always want to know when was the last time that a piece of information was advertised. And essentially, if there is missing information in this packet, and you have not refreshed the information lately, I'm discussing the part in green now, what you want to do is enter the lifetime avoidance mode, meaning we want to double check whether this information is current. And essentially, we enable this mode. Again, we just receive an incoming array, we record a timestamp of when the information was last received. And if the incoming array contains missing information, so there's stuff that was advertised by this local router before, but it's not being advertised now, we want to get into the lifetime avoidance mode, or in other words, we want to prove the local router to see if this information is really gone, or maybe it was just sent in a different packet and it was lost on the way. Okay, next slide. So this part is actually, in this case, it looks like slightly more complex because we are considering two things. Like on the one hand, we are considering that configuration information may be included or may be split into multiple packets. That's one thing. And we are also making the algorithm general enough that if you want to poll the router more than once, you can do it. Okay, so in the first image that I covered, that I shared with you, essentially we were assuming just a single RS probe. But for multiple reasons, you might want to say, well, when I want to verify whether the information is current or not, I don't want just to send a single router solicitation. I might want to send 2, 3, whatever the number is. Okay, so this part of the algorithm is trying to cope with that. But still, it's super simple. So when you are in this lifetime avoidance mode, like you are refreshing, you are verifying whether the information is current or not. The part that we have in yellow essentially says, if we have gone through the entire testing phase, meaning we send at least one router solicitation, but if we wanted to check multiple times, we send more than one router solicitation. When that time has elapsed, then what we have to do is, if there is information that is still missing, has not been refreshed, just disassociate that information with the local router. Again, the fate of that information will depend on whether that information is being advertised by other routers or not. So it could be advertised by multiple routers, and if only one of their routers is ceasing the advertisement of that information, we just say, okay, this router is not advertising this information anymore, but we might keep this information because other routers keep advertising it. So in yellow, we just say, the test phase is over, the refresh phase is over. Anything that has not been refreshed, we phase that information out because it's a stale information. And then what we have essentially in green is just checking, with like protocol variable, which of course are all defined in the in the draft. And essentially we say, after we have sent a router solicitation, after a period of time, say 3 seconds, that this RS times out, then we have two options. Option one is that we might want to send a new RS, like prove the router more times, or if all of the information has been received, we just say, okay, test phase or refresh phase is over because we have just refreshed all of the information, so everything's okay, no stale information. So it's just a matter of looking at the constants. It looks it might look more complex than it actually is. It's got an array with missing information. You decide to prove the router with a unicast router solicitation. If the information is refreshed, we keep the information. If it's not refreshed, we remove it. That's it. And this makes it I would say the algorithm way more robust than in the original individual submission, and way more simple too. Next slide. So far with this last bit, we have gone through all of the pieces in the original document. Obviously, there are things that have been modified, improved as we went through this process. So from our perspective, our question to the working group is whether the document is ready for working group last call. Lorenzo.
Lorenzo Khalid. Yeah, I think so. Document is doing a lot of stuff, and I think most of it is good. I'm sort of very skeptical about this sort of active avoidance stuff, though. It's very complicated. It would be a big change to existing stack implementations, and it requires forking off a bunch of implementations, sort of forking off a bunch of information, essentially duplicating it by every router. Right now, like right now, the semantics of a particular piece of information are like whenever you get it, you store it. But now you have to like actually store everything that everybody sent you, just because you think you might, because you think that guy might forget it, right? So I think it's like very complicated, and I'm not sure it's actually very useful in most cases, because we know that in most networks that actually have this memory loss problem, in many cases that the AP is co-located with the router is co-located with the layer 2 device, so you don't actually have this problem. So I guess what I'm saying here is the other thing that concerns me is that it's, I think, overspecified. As an example of why I think this is bad, consider like another thing that you're trying to fix in this document, which is 553E, which is the 2-hour rule, right? The 2-hour rule is clearly overspecified, and we have a lot of trouble with it right now. We want to get rid of it, but it's really hard because we have to update sort of a 48061, right? So I would really try to sort of be a little bit less ambitious, and maybe if you really want to specify that hosts need to like try to help routers when they've forgotten, I think we should have more general notes rather than put a specific algorithm into here, because I think this RFC is going to last whatever years, and a lot of implementations may not be able to do this easily, right? So yeah. Another point that I have is sort of more technical is I think the suggested lifetimes assume low packet loss, and this is not the case. So on a typical mobile device, on a Wi-Fi network, you will see at least 50% packet loss from multicast, typically much more. And so the current guidance in there, I think, will break most devices today, most mobile devices today, because you'll send way fewer arrays, or rather you'll lower the lifetime. And anyway, just plan for mobile devices in the field experiencing at least 66% packet loss for arrays, and rerun that through your algorithm. Another example of why this is kind of overspecified, because this is very implementation dependent. It depends on like the generation of the device, the type of Wi-Fi chipset, and the power saving technology. So again, try not to overspecify. What this all means for last call, I don't know. But I do think these need to be dealt with before we sort of advance this to a standard.
So one comment I'd like to make about that most of, if anything, the complexity that you might see in the in the current algorithm is that we are coping, or we are embracing the case of multi-router, multi-prefix. The RFC number, it's escaped me, but that's the RFC authored by Brian Carpenter and Fred Baker. And the thing is, we could get the algorithm being simpler, but the thing is that you actually need to do this thing to actually for multi-router, multi-prefix to have any hopes of work in practice. So that's something that, the thing is, obviously, implementations are not currently implementing that, but that's why multi-router, multi-prefix is broken right now. And the only other thing that, I wanted to add, not responding the whole thing, is that I have this exact problem in my own network at home.
Okay. Yeah, okay, I put myself in the queue, Jen Linkova, no hats on. Just a clarifying question, actually, because I'd like to second a lot of things which Lorenzo said, but I have clarifying questions. Your drafts in your presentation seem to be using a term configuration information received by a host, right?
Yeah.
What exactly does it mean? It looks like you implying prefix and PIO, but is it the whole PIO? What if flags and PIO changed? Or is it any other information and array, like anything else? I think it's not clear, right? And it looks like you're talking about particular prefix, not even the whole PIO, just a prefix bit. So do you see any other cases in mind, or you actually mean prefix?
Yeah, so the original document was just talking about PIOs, but as part of the discussion with the working group, and actually as part of the discussion that we had in Basics Ops with the other two documents, this document talks about, when it refers to configuration information, that is PIOs, route information options, and the two DNS options, DNS server and DNS search list. Because at the end of the day, if the information has become stale, the DNS information might have become unusable. So those 4 pieces, it's listed in the draft. So I didn't mention this in the slide for space reasons, but it's listed in the draft.
Okay, thank you. Tim?
Yeah, Tim Winters, QA Cafe. So 2 things here. One, I want to echo what Lorenzo said about the algorithm. I'd be very concerned, having tested lots of implementations, about trying to implement that algorithm in there. I think that's a little aggressive, and maybe we could come up with other ways to solve that problem. My second comment is you changed a lot of the lifetimes, which I think is interesting. The only thing here is I would put some text in there talking about a lot of routers are getting their information from prefix lifetimes, from IAPDs. And you don't have any text in there about you should shorten the time or do anything with that. I don't know if you want to change the PD default lifetimes. I don't think you need to, but I think you should definitely talk about, hey, if you're learning this stuff automatically, you probably want to shorten it if it's over X amount of time, something like that.
Yeah, that's a fair point. Thank you.
Yeah, Eric Nordmark. Yes, I have sort of similar concerns around complexity in general. So trying to solve the multi-prefix, multi-router one is hard. But my concern that I wanted to bring up at the mic was what happens in the simple case? What causes this to be triggered? If I have a single router that advertises a couple of prefixes, can this algorithm accidentally be triggered where it basically ends up sending some RSs and then giving up and thinking that things are broken when in fact everything is fine? And maybe the router decided to drop one of the prefixes, which could be perfectly normal, right, over a long time period. So you don't necessarily want to trigger this stuff unless you think that there's a need to sort of flush out information prematurely, right? And because we don't want to accidentally introduce some operational instability that isn't there today in those sort of simpler cases. So have you looked at this part of it?
Yeah, so I have not seen myself, but I have not that. I mean, what I'm saying, like I haven't seen it myself, which means in my existence I just haven't experienced that. The case where there's like cases where the router ceases to advertise a piece of information, advertises a different thing, and the previous information is valid. But this is what I've seen. I'm not saying that that doesn't exist. So the cases where yeah.
But what causes you to sort of get into the mode of saying you need to revalidate information by sending RSs, etc., or unicast arrays and what?
Yeah. So in the algorithm, what we say is we keep a track of what this local router, the information that the local router was advertising. For example, it was advertising some prefix. Okay. Now, if that prefix is not advertised anymore, we keep hearing from the local router, but it's now advertising a different thing. We are not hearing from that router anymore about that information. That makes us wonder, well, what happened in there, right? In the normal scenario, the router will keep advertising the same information. But we try to cope with cases where, for example, these are in reality corner cases. Like we try to cope with a case where a router might split information in multiple packets. I haven't seen that in the real world, but the spec allows for that. So the router could, theoretically speaking, split the information into multiple packets, and one of such packets might have got lost. That's why we just don't want to give up because the information is missing in a packet. But actually, before we do that, we want to do a unicast poll to the router and see, what is the information that the router keeps advertising.
Yeah, Lorenzo Colletti, I think what Eric didn't say explicitly, or maybe I just realized it right now, is that the fact that a router drops stuff from the RA doesn't mean that it forgot who it was and where it's coming from, right? It might have decided to just drop it and wait for it to expire. And this algorithm actually changes those semantics, because the host basically says, oh, wait, it forgot. I need to delete it. And that's actually a change in semantics. So we have to additionally think about the fact that this might break deployed networks if you do this. Or existing operational practices, rather. Look, I think one other thing that I've said about this document again and again is that we keep trying to solve this problem in one RFC and we never get there. I really think we should split it and say, okay, there's stuff that's simple. 552E or whatever it's called, just let's delete it. We all agree on that. Let's kill it right now, because that's actively harming us. It's getting in the way of deprecating stuff, right? The lifetimes, I think they're also pretty close. We need to be a much more accepting of packet loss in the real world, because a lot of mobile devices just drop these packets for power reasons. But that's also something that I think we can get close to published soon. If we keep trying to make this algorithm right, I think we'll just keep finding a lot of corner cases and just take us a long time. So I would kick that algorithm out of the RFC or of the draft, publish, and then sort of attack that problem sort of with more experience. Also, once we deploy some of the fixes that we will have published at that point, we may find that the scale of the problem has gotten less severe, and maybe we can live with it. So anyway, yeah, keep it simple. With MP multi-prefix multi-homing, I do agree that the host will have to remember a bunch more stuff. The fact that only one known implementation has done 5.5 suggests that this is really hard to implement as well. Agree that we should do it, but that's another point that should give us pause with the complicated lifetime avoidance algorithm. 5.5 doesn't even require you to send any packets. All it does is store the information correctly, and even that's not implemented in Linux and iOS, right? This algorithm is well, I forgot this. Okay, let me send the packet and receipt of this array. Let's check. Let me set some time. That's super complicated. In Linux, this is all done in kernel space, and that's complicated enough. Or if you want to put it in network manager, I would argue that's even worse, because the network manager can't even do privacy addresses correctly. It delegates that to the kernel. So I think this is way too complicated to actually get implemented correctly. Sorry, I keep saying that, but.
Yeah, so essentially from our perspective, there were two different paths. One was to, forget about the multi-router, multi-prefix thing. Probably the algorithm, people might agree or not, that's a different thing, but the algorithm would really be way simpler. But would be one thing. But the thing is that if we don't, that would be assuming, okay, multi-router, multi-prefix is broken. Then option 2 was to try to embrace the multi-router, multi-prefix thing. I'm fine either way. Or even if the working group decides to, for the algorithm to do at the separate document, again, I'm fine either way.
Okay, thank you, Fernanda. Just for sake of time, I suggest we continue the discussion during the last call on the list. So Tom is next. Tom told me that he could either receive audio or send audio, so he'll be operating in half duplex mode for his presentation. Okay, Tom, please say something so we can confirm we can hear you.
Can you hear me now?
He can hear us. I'm chatting with him.
I can hear you.
Okay, Okay. Sure.
So my name is Tom Herbert. I'm going to give an update on the draft for limiting extension headers. Next slide, please. So first, covering the changes. So we're at version 2 of the draft. There were fairly minor changes from version 1. So one of them is a disclaimer that the mechanisms to determine when a limit can be exceeded, those are out of the scope for the draft. So you can imagine that when we're trying to send packets with extension headers that exceed one of the specified limits, it's okay to do as long as the sender knows that it's safe to do. The mechanisms for finding whether or not it's safe are basically out of scope for the draft, although we do give some general recommendations for that. We also reference the hop-by-hop processing draft, particularly pertinent, I think, is the handling of the high order 2 bits for an unknown option. We added a motivation that allows an intermediate node to stop hop-by-hop option processing and forward a packet in the cases that it encounters an option where the first 2 bits are non-zero. So this is sort of a simplification in processing, where instead of going through the dropping and potentially sending an ICMP packet, a node could in fact basically just ignore the hop-by-hop option, stop processing there and forward. This is consistent with our model that nodes can process any number of contiguous hop-by-hop options. So seems to be safe to do in that regard. Then there were a number of text edits also. Next slide, please. So I wanted to cover one of the areas. I had an off meeting with Bob and Gory about this draft and the hop-by-hop processing draft. So one of the statements I think Gory made was that we wanted to make sure the motivation for the specific options is clear. So I want to cover those today as kind of the bulk of the presentation. So the first one that I want to address is the default number of non-padding options. So in the draft, we specified that nodes by default can send up to 8 hop-by-hop or destination options, non-padding options in a packet, with the expectation that that's safe to do, and the receivers either will be able to process all of those or at least be able to process some subset or none of them. So the reason we came up with 8, it is a manifest constant. So we have to demonstrate somehow it's future-proof. So the analysis showed that in the history of IPv6, I believe there's only been 13 non-deprecated, non-padding options defined. The rate of adding new options seems like it is increasing. However, we also have to consider these are really options that would be used primarily on the internet for limited domains. As I said in previous presentations, if you're sending into a limited domain, it's much easier to go beyond the limits that we're recommending here. So this is really, the default options are for unknown networks, the internet itself, or a domain where we don't know exactly what the capabilities are. So at the rate of adding new options is very low. We also have some anecdotal evidence that hardware like P4 could handle up to 8 options. It's potentially possible to put those in a CAM, though I think that would be a little difficult. But we are looking at some implementations that can get parallelism. 8 seems like a pretty good number. It's low enough that we could actually parallelize that. So the conclusion that the draft came up with is that 8 is sufficiently future-proof. So it's not too restrictive. And on the other hand, it does seem reasonably feasible. And again, the value is just the limit for sending, not the limit for processing. For the limits for processing, as this draft and the hop-by-hop processing draft specify, all nodes or any node could actually ignore all the hop-by-hop options, or they could process the first contiguous set of them. Next slide, please.
The padding options with defaults, this is a little more straightforward. All this really required was looking what is the real use case of padding. And the conclusion was it's just for alignment of options primarily. There may be some other use cases, but again, I think those would be outside of the normal limits. And if somebody wanted to use padding, for instance, to make a packet larger, that's fine as long as they understand the consequences of the path and it's safe to do. So the defaults that we came up with, maximum of 7 bytes. That means we can align up to an 8-byte field with 7 bytes of padding. And also the other part of that is only one padding option, one contiguous padding option allowed. So pad 1 gives 1 byte of option, pad n can give the 2 to 7. So as I said, there's no practical reason to do this. Also, this really isn't an issue for networking stacks that are sourcing options. It's very, very easy and probably much preferred to send the minimal amount of padding. It's less processing on the sender. Next slide, please. So the third motivation is the IPv6 header chain length. This, of all the limits described in the document, really is the one that is most, the hardest requirement, I would say, in terms of being an actual requirement, because it does affect the receivers on the internet. In particular, the requirement is that intermediate nodes can process at least 128-byte header chain. And this really has to do with those nodes that have to process the transport layer header. So what this basically saying is we expect that there could be 128 bytes of IPv6 header chain. And if those nodes have to look into the transport layer, they should be able to handle that. So the rationale for 128 bytes comes from, first of all, evidence in the field. So we do know that 128 bytes are fairly common, and this was a result of some of the kind of ad hoc information gathering we had when we did some of the tunneling exploration a few years back. Many devices already process encapsulation. So if you're processing encapsulation, they will have to, by definition, be processing more than the IPv6 header. So that already puts us deeper in. The question then, assuming that that's a sufficient minimum, should we have a larger default size? One thing I would note is there's already other limitations to this. In particular, RFC 9000 quick, in some cases, will limit extension headers to 32 bytes anyway. So with the 128-byte header chain length, by the way, that implies that the maximum extension header size is 64 bytes. So it's a little bigger than the quick limit. But again, the rationale here is we expect that nodes, intermediate nodes on the internet, can minimally be able to process this without dropping the packet or without causing detrimental behavior like bad routing. Next slide, please. So that being said, we did post version 2 of the draft. There were not a lot of comments on the list. Last IETF, we did address several comments, particularly from Brian Carpenter. Also, we will obviously continue to work with the hop-by-hop processing draft. I think they're going to have kind of bidirectional normative references. And in any case, I think the question now is this ready for working group last call?
Okay, thank you. Any questions? Do not see anyone in the queue. Okay. In this case, I guess we'll issue. Eric? Okay.
Can you remind me if this document has had a routing area review?
Hold on. Yeah. Tom, can you hear Eric?
Yes.
Hey, Tom. Sorry, yeah. Can you, can somebody remind me if this has had a routing area review? If not, I'll request one when we go to WGLC.
So is that up to me to initiate, or?
No, that's chairs or myself.
Okay, yeah, yeah, very good point. Thank you. We'll take care of this.
Yeah,
Okay.
I think
Yeah.
we should have some confirmation from other routing people to say this is good. Thank you.
Makes sense.
Okay, so in this case, if there is no one else in the queue, no comments, we'll discuss it with, we'll ask routing AD. Anna? Okay.
All right, thank you.
Okay, we have where? Yeah, use this mic, Anna.
Just a comment that in practice, I've done some measurements with hop by hop and destination options, and I found that as soon as your entire header exceeds something like 105 bytes, then things start to get dropped massively. So that's just a comment on your 128 byte choice there. I can share the
so
data.
there was some good data on that. I think there was some fairly fresh data. It's kind of a, if we make it too small, that would effectively say hop by hop options aren't useful. So I think this is a min-max problem. We obviously want the largest possible, but there's a minimum here. If we say that the minimum is 64 bytes, for instance, that effectively means we couldn't send any hop by hop options, because you have to account for the, in the parsing buffer, you have to account for the Ethernet header, the IPv6 header, and at least 4 bytes of transport protocol. So that puts you up to at least 54 bytes there. So it is, like I said, it is the one requirement in the draft that's a little bit, I guess, forward-looking in that sense.
Oh, that's right.
There's not going to be a perfect answer to this, unfortunately. We know that there's nodes out there that require examination of the transport layer header. That's really what we can do. So it's either don't use hop by hop options to satisfy them, or try to come up with a meaningful requirement that's kind of balanced between, yes, they want to do that. They want to look at transport headers in a practical way. On the other hand, we do want to make sure that we have an extensible protocol.
Thanks.
Thank
you. Fernanda?
Yes, so I haven't been following the document recently, but I briefly skimmed through the document before the meeting, and I like a lot the current version of the document. One question when it comes to the limit that you suggest, or the minimum limit, and I think that's related to what Anna was mentioning, is whether the minimum value that you want to, let's say, recommend or specify, whether that is a value that, based on current experience, is what, for the most part might work, or is it a value that reflects where we want to get at? Which would be okay either way, but I guess it would be a good thing to know whether, it's something that we say, okay, well, so far based on the testing that we have done, this specific value for the most part would work, versus, well, it's not really working right now, but we would like at the very least to support this value that we are proposing.
So I guess, Fernando, so you had done the work to describe the problems with extension header drops, and one of the conclusions was this problem, right? So yeah, extension headers could force the transport layer too deep in the packet. So I don't know if we have data on that. I think it's definitely a real problem. Some of the empirical data does indicate that there are still nodes that are very conservative and will drop packets with almost any extension headers. So I don't know how we could solve that. But in case, I think maybe that would be a good discussion to have on the list, is any more of the specifics of that. So like I said, I don't think the empirical data has been gathered for really making a specific judgment. Like I said, there is anecdotal data towards this. I do think that having a minimum requirement in general is a good idea. We need to give the vendors some sort of guidance here. And I think one of the major problems is we haven't given them the guidance. So they've been able to take a lot of leeway with the protocol standards, unfortunately. And again, what we're trying to do is create something that's feasible. Maybe does give us a target, but I do believe we have to set something, at least in sand, to get this moving forward.
Yeah, I believe that as long as it's clear whether we mean that that's where we want to get versus whether that is working right now or no would be useful. On the one hand, it might be the case that we want to specify value to say at least, okay, we get here when it comes to the support. But at the same time, I believe it to be, we don't want people to read the value in the wrong way, and maybe if that is actually a target as opposed to what is supported right now, we don't want people to rely on that value and then find out that, well, actually, if we send packets with that length of an extension header chain, my packets will get dropped. You know what I mean? So I believe that as long as it's clear, it's okay.
So packets are going to get dropped. And I think the whole saga of the extension headers it's not a problem we can solve overnight, right? And it's an evolutionary thing. The hope is that we can set up some limits, and that those legacy devices that don't support the limits, they'll eventually get phased out. It's going to be really difficult to get to 100% support, so we will need other mechanisms. But yeah, I think it's an aspiration, but I also think it's a realistic aspiration.
Okay, just for sake of time, I suggest, we can take this discussion to the list. Next presentation is, again, let's continue with extension headers. Hop by hop processing procedure. Gori, do you like me control the slides or you'd like to present?
I'd like you to present, please.
Okay.
I'll just. So this is the hop by hop processing draft by Bob and me as editors. Next slide. So we're currently at revision 6. We did 2 changes since the last meeting. We moved from 4 to 5, where we did many edits, and we moved from 5 to 6, where we added just one thing. We've also got a slide talking about next steps. Can we have the next slide, please? So the changes from 4 to 5 were the more significant ones. We made a definition of full forwarding rate. We needed text for this, so we made text for it. This is not a science exercise in how you determine the full forwarding rate or what we want to pin down by the full forwarding rate. We simply want to say it's the rate at which you can forward packets across your interfaces. And we want to keep it a little bit open because I think different architectures are going to be different. But we want to keep it sufficiently clear that what we mean is it doesn't slow down processing, forwarding, when you have the hop by hop extension header. So that was a tricky bit. The easy part was we added a small section on potential reordering. That was a great call from to add that. Potentially, when you add an extension header, things can get reordered. So be aware when you have a different processing path. We added a small block of text that says nodes should process the hop by hop option header. It was always our intent to say this. And if the node does not process the hop by hop option header, it must forward the packet normally. And then we added the straightforward to process sentence, which said straightforward to process. We defined that as new hop by hop options should be designed to ensure the node can process the options at the full forwarding rate, e.g. on the router's fast path. So these were kind of little tweaks, little changes to the text to try and make sure that we covered all the comments that we collected so far. Can we go for the next slide? We discovered one extra thing. We didn't really need to mention RFC 6564 because it's discussed in RFC 8200. So initially we thought maybe we won't talk about this. And then we saw that there were actually some recommendations for hop-by-hop processing in that specific RFC, which were rolled into RFC 8200, and maybe a little bit more also that wasn't. So we've added a actual reference to this so that people can go back and see this RFC and then see the current RFC, and they know that this is being taken into account. So no real change resulting from this, but this was to keep the citations clear. If people go looking for old RFCs, they know where they've actually been used to build. Next slide, please. A summary on the usefulness of hop-by-hop options, just as we begin to try and motivate that this should get a working group last call, which is where we're heading for. The reason we did this work was we believe that some paths do support hop-by-hop options. It's not a belief, it's something you can test. They actually have many paths where you can use hop-by-hop options effectively. There's currently high drop rates on some paths, so you have to decide when you're going to use hop-by-hop options what you're going to do about the possibility that the particular path you're using has a high drop rate. What we would like to do is see a change so that this drop rate reduces with time. We'd like to see new recommendations, and that's what hop-by-hop processing tries to do. We believe that limiting the size of extension headers improves traversal, and therefore we make recommendations to use a small number of hop-by-hop options and get them through the internet. We'd love in the future for people to have bigger parsing buffers and allow us to do bigger ones, so it doesn't stop us doing larger hop-by-hop options, more hop-by-hop extension header bytes. But that's probably going to be something that happens later rather than sooner. Let's try and get things working. Various data has been presented most recently at IEPG, and there were two presentations, 115 and 116. If you want to dig back in IEPG to look at those, they give you something about the story and the summary of the different measures that have been made for hop-by-hop option traversal. Next slide, please. So where are we at after this? I went quite quickly through this because I think probably we're reaching the end of what we can do unless people provide new feedback. We realize that the EH limits draft does have a relationship with this, but I don't think it would cause a issue to let us do a working group last call on this particular document. So I suggest we do the working group last call for this, and would like to ask the chairs if we can do this. Can we do a working group last call on this document? Do people have more comments? Next slide. Was that last slide? Yeah, last slide. Oh, okay, go back slide then, please. Fernando.
Hi, Gori. Can you hear me? Good. I have like two, questions or suggestions, if you wish, or just to put something on the table. So one of the sections you mentioned, let me see what section that is. It's section number 6. The document says the size of an option should not extend beyond what can be expected to be executed at full forwarding rate. I have just skimmed through the document, so I might have missed it. But is there a hint of what that value is? Like if I wanted to follow the advice, what would that number be? Would that be 64, 128? What would be that value?
We don't have a number.
Because I believe that even if it's in line with what Tom was suggesting, I have no suggestion for the value. But I guess that for a folk reading the spec, if it's a host that is going to, let's say, craft a host by hop options header, it's like, okay, what's the limit that I should use? Okay, I'm game. Like I don't want to exceed that value. Okay, what's the value? So I try to come up with something. I don't have a specific suggestion about that, but something that is a hint that, okay, this would work. I don't know what the number could be. It could be 64. I don't know, to be honest. But it could, I guess it could be something, well, again, same discussion or same comment that as I made to Tom. It could be one of the two things. It could be something that it works, kind of like it works right now, or it could be something that, well, it's not really working right now, but could be a trade-off between having the whole thing, like, sending a header of any length that you want, not that, but also not maybe the short length that might be supported right now. But I think that one way or another, it might be good to to come up with a suggestion of what that value might look like. I mean, obvious values could be 64, I guess 128. I have no idea.
This number is probably not as easy to get to as we might hope. I think it depends a lot on your hardware. It also depends on whether you have other extension headers apart from hop-by-hop headers, because the thing that fails might be the ability to find your port information that's rather deeper in the packet than the extension header problem. So putting a number here to say, well, if you do this much, it will work, is probably a recipe for a disaster. Unless, I mean, there is no number that you can guarantee will work. Smaller numbers work better. I mean, is that useful advice?
Well, what I would say is, like, if I read the spec and I say, well, I want to comply with your advice, I want to follow your advice and not, create a hop-by-hop options header longer than what would be forwarded at full rate. Okay, I'm game. So what's the value? So I should create a hop-by-hop options header that is smaller than. And I guess that's where the part of the question is. What would be something that at least, when I did measurements like a while ago, there was a value. I don't remember if the value was like, could have been 64. I don't remember the value, where things would start to fail like super abruptly, like super bad. Or it could be the other way around. We could say, well, we don't want to target that. We want to, at least try to get something that is better. So right now, yeah, you are going to get dropped, but we want everyone to at least get to support whatever value. Could be the 128 bytes that Tom was suggesting. I don't have like a specific comment on that one. And so that was one of my comments. And the other comment was that in one part of the document, which I believe it's good. It says that well, you should be expecting like a single hop-by-hop options header. If you get more, you may ignore those. My question in that respect is that if any other hop-by-hop options header, it would be okay for systems to ignore them. Should there be a recommendation? Maybe there is in the document, I just missed it. But if we are suggesting that further headers might be ignored, could we actually make a recommendation to just include a single one? Otherwise, you'd be in situations where people include multiple, but at the end of the day, you don't know what's going to happen with the second, third, and whatever.
Yeah, you don't know what's going to happen with the first even. So I'm not sure that limiting this to one really is a great thing. You really will constrain what router vendors will actually put in their products, which means you will only get one, ever.
That is correct, but that's still better than the feature not working at all. I agree with what you're saying, but on the other hand, it's like, well, if you don't constrain it, like, right now, your people could, create like a 1K, extension header chain, but yeah, well, that doesn't work. In theory, they can, you have not constrained them, but in practice, you get nothing. So I would rather settle for something that works as opposed to like, in theory, everything could work, but in practice, I cannot use the feature. That's where I'm coming from, at least. But this is just an idea.
Okay, I hear your questions, and we don't have real answers to these because I'm not sure we want to constrain the way that it will evolve in future. So let's think and talk a bit more on the list if that's helpful.
Cool, thank you.
Yeah, Tim.
Tim Winters, QA Cafe. At the top of section 5.2, you say nodes should process hop-by-hop headers. Do you mean routers or do you actually mean hosts as well? Because I recently we were doing some testing and we've had some hosts do some really strange things with hop-by-hops, AKA ignore them. And I sort of had to walk the vendor through how that works. So we might want to be careful about the words we use here. I think you mean router, and you definitely mean router in the next sentence because you say full forwarding rate. So I'd be very careful with the words we use here because the host vendors will go off and do strange things.
Bob, are you able to comment on that one? Whether we should use the word nodes or routers?
Yeah, I think we should go back and take a look at that. I think it's a good comment.
Tim, can I just ask what you mean by ignore? Did you mean just not process, or did you mean drop the packet?
Okay, so they actually did something horrible and they dropped the entire packet. So I had to explain to them that's not what ignoring the hop by hop option meant in 8200. And I was a bit horrified, to be completely honest. They, obviously couldn't process the next header was their argument, is they could ignore the option and then not worry about what followed it. And so I explained to them, like, that's really awful, but I'm scared how many people might read that and do those kinds of strange things.
Well, okay, the sentence says if the node does not process the hop by hop option header, it must forward the packet normally.
Yeah, this is a big improvement over 8200 for sure, but the problem is it says forwards, and a host isn't forwarding in that case. It's the end node.
Yeah, so it looks to me like we need to look at terminology a bit here, and make sure that we use an exact words we actually mean in the draft, because I myself I know how easy it confused hosts and a node. I think it's just kind of editorial review will be required.
Okay, we'll do that.
Just one side comment. I don't think the chairs.
Please say your name so minutes takers could put it in the meeting minutes, please.
Fair point. My name's Tom Hill. I work for BT. This is just a side comment, though. If I could make a plea to Fernando to turn down the gain on his microphone. I don't think the chairs can hear from where they're sat, but he's deafened most of us so far. So, as I said, just a side note.
Okay,
so we will revise, and we would ask for a working group last call when we've revised.
Okay, thank you. So we'll wait for new revision and then we'll issue the working group last call as soon as it happens. Thank you, Gore. Now we're moving to individual drafts on the agenda. And I guess the first one we have is tracing process in V6 VPN tunneling networks. Shopping.
Okay, so this work is about tracing in IPv6 VPN network, and it has been discussed in the mailing list, and we have received some very constructive comments, and accordingly we updated the draft. Next, please. So here today, I will first briefly go through the background, the scenarios, and then I will focus on the requirements and the needs, and some summary of the discussions in the mailing list. So first, I'm sure you are all familiar with the ICMP v6, and the RFC 4443 has described it. And especially for the time exceeded message, and here is the format. So basically, when the halt limit of a packet becomes to 0, the router will drop the packet. And then this time exceeded message will be sent back to the source of the packet. Next, please. Okay, so please focus on this diagram. I will talk you through. So first, let's take the IPv4 packet example, and it is being sent by the CE1. And when the packet reaches the PE1, and the packets will be encapsulated in IPv6 tunnel, and the halt limit in the outer tunnel header will be set according to the TTL in the original IPv4 packet, as well as the configuration in the PE1. If it is a uniform mode, the hard limit will be -1. And if it is pipe mode, it will be set as the maximum. For example, the 255. And when this packet reach to the P node, if the hard limit becomes to 0, there might be two cases. So first is the routing loop might has happened. So in that case, the packet will be dropped and a notice will be sent out. And in the second case, that will be a normal tracing. So in that case, the ICMP v6 message will be sent back to the PE1. And then the ICMP message is for the V4 message and will be sent back to the CE1. Okay, next, please. In order to correctly construct the ICMP v4 message at the PE1, there are some information is needed. And first, for is the source address of this message, you would need to know the v4 address of the access interface at the P node. If the P node doesn't have the v4 address, the v4 address of the PE1 node will can also be used. And also, you would need to know the VPN information in order to associate this message with the original packet. Either the VPN ID or the access interface information could be used. So currently, those information is missing. So it's better to have like a mechanism to be able to carry it. And also, we would need a mechanism for the node P to determine, excuse me. So what is the cause for this zero hard limit at P node? So is it because of the routing loop or it's a normal trace? Next, please. Yes, so here is a summary of the discussions in the mailing list. So first, whether the VPN information could be extracted. For some tunnels, that is possible, but for others, for example, the SRv6 is not possible to have this VPN information. And also, it's because the PE nodes has low capability to extract this ICMP v6 message. I mean, those information needed from those this message. And that's true. But since the trace packets are control packets, so we precise these packets on the control plane of the devices. And we were also suggested to define some new message types. And here, basically using ICMP v6 to carry the v4 addresses of the P router, as well as the ICMP message to carry the v6 address of the P router. Okay, next, please. Okay, so finally, this is the suggested proposal. And basically, we proposed IPv6 tracing option to including the information we mentioned before. And I won't go into details, so please read the draft and the comments either in the mailing list or directly to us. Thank you.
Okay, Eric.
First, Chupeng, thank you for the draft. I think it could be useful.
Thank you.
Just wondering now, if you do a trace route and you receive all those ops being always coming from PE1, this will be quite confusing. And the other point, when you exit the tunnel, do you copy the TTL into the hop limit in the IPv4?
Yes.
Okay, thank you.
You referenced 3443. That's actually like an MPLS tunneling document. I think for IPv6 tunnels, which you diagram depicts, you might want to consider looking at RFC 2473.
Okay, thank you.
And there's a section in there about how to handle hop limits and decrements and so on.
Okay, we will check. Thank you.
Thank you.
For remote participants, it was Eric Klein. Okay, any more questions? Your last chance? Queue is empty. Okay, thank you very much, Ben.
Thank you.
So the next presentation will be about a new proposed P option. So Lorenzo will tell us something about new options concerning DHCP-v6. Please pay attention.
Yeah, Lorenzo Colletti. I spend most of my time working on DHCP-v6 these days, which is, I don't know if that's a good thing or a bad thing, at least here at the IETF. Okay, so next slide I say, well, this is a companion to a draft that we presented in V6 Ops earlier this week. And it's work with Chen and Xiao, who is actually also working on the implementation of PD on Android. What is the problem that the V6 Ops draft is trying to solve? Well, we have a lot, hosts always have multiple addresses, right? We link local stable 464x lat, you need to do renumbering. And on some networks, particularly enterprise networks, that's a big problem for infrastructure. I mean, we know vendors that limit, to, let's say, 6 or 7 IPv6 addresses and just drop everything else. And we know of OSs that use more than that on a regular basis, and they just don't work. The new addresses don't work. And so that creates a big scaling problem. And the draft in V6 Ops proposes that you use DHCP-v6 PD for this so that the host can create as many addresses as it wants, give everything, all of those addresses end-to-end connectivity without having to place any scaling burden on the network. On the other hand, if we do this on smaller networks like home networks, you will basically exhaust the prefix space in home networks because some home networks just give you a /60. Mine just gives me a 64, so this wouldn't even be possible at all, right? So what we're trying to do is we're trying to define a way to tell the host what prefix allocation mechanism to use, how to form addresses by itself, how to auto-configure addresses, basically. So this is not a replacement for Slack because it will actually relies on Slack, as we'll see later on. If you think about this in any way related to what we have today in DHCP-v6, you might see this as a replacement for IANA in enterprise networks. But next slide, please. What are we talking about here? PD is actually sort of a well understood standard. It's RFC 8415. I don't even know if it's a full standard, but it's definitely very mature. And the standard already supports doing it on hosts. So why do we need to come to 6-man? Well, again, we need to communicate to the host whether PD is supported on this network or encouraged, right? So we adding a flag to the PIO that says, if you understand this flag, you can use DHCP-v6 PD. Don't bother to use Slack on this PIO. Just do PD, get your own prefix. And we need this because in an enterprise network that supports both existing and new devices, we need to make AutoConf continue to work. For example, like the Google network, the enterprise networks uses AutoConf extensively only. And if we want to migrate to this, we need to support this flag so that older devices don't use AutoConf. Why does this flag need to be in the PIO instead of in the RA? Well, it's got to be there before you start AutoConf, which means it's got to be in the RA. And also, it's specific to a particular prefix. So for example, some networks might want to say, well, get a prefix for global connectivity, but use AutoConf on the ULA. Or maybe more likely, in a multi-homing situation where you have two sort of PBDs on link, different upstreams might support, one upstream might support this and one might not. And so we want to be able to support this, and hanging it off the PIO is sort of a way to do that. Why not do more of this in DHCP-v6 itself? Well, there's some IPR that we need to tread carefully around. Somebody wanted to, I think a long time ago in MIF, we tried to add some PBD options to DHCP-v6, and there was some IPR claim that just killed that. And so we haven't looked into that, but this is, we need to steer clear of that. So next slide. How can you use the delegated prefix? Well, it's yours. You can do whatever you want with it. You can create 1 billion addresses if you want, and it's not going to cause the network any scaling issues or any pain, and it doesn't matter. You can use this to assign IPv6 addresses to internal components, VMs, containers, whatever you want, Docker containers. They can all have end-to-end connectivity without NAT or NPTV6, which I think is a huge improvement over what we can do in IPv4. This is really not possible in IPv4. You can't have 100 VMs on your host at home and give all of them end-to-end connectivity. And even with Slack or DHPV6 on an enterprise network, you can't do this today, even with IPv6. So this really gives you, because the network will fall over. And so I think this also gives us a meaningful increase in the abilities that we have to do end-to-end connectivity today, even compared to Slack, right? So I think that's important. And also the host may, if permitted by host policy, not network policy, it may extend the network. It can send an RA internally. It can send an RA to tethered devices, which is what we use today for IPv6 tethering. Now people have said, well, I don't want my host to extend the network, but the truth is that that's up to the host. The host can do NAT4.4 and extend the network as much as it wants. And it can do NAT6 if it wants to. There's plenty of implementations. All we're doing is making it so that the host can extend the network without losing end-to-end connectivity. Next slide. So there's a few sort of issues here, right? For example, DHPV6 is not very good at reconfiguring things. And so, you know, when we want to make sure that the properties of Slack in terms of renumbering and deprecating prefixes and multiple prefixes and so on are all preserved as much as we can. And so we basically say that as long as there's any PIO with a P bit set to 1 on the network, you should keep a DHPV6 PD client running. Anytime that set of prefix changes, you should probably do a rebind. Actually, folks have clarified that rebind is okay, but basically kick PD again to say, okay, like, has a new upstream showed up? You know, do I need to, like, is something become deprecated? Should I, you know, like, get more information from the servers? And yeah, again, reconfigure is very hard to use, so it's sort of difficult to use this for this purpose. Did you want to ask a question now, or did you want to go at the end, or up to you? Okay, next slide. For multi-homing, obviously we need to support multi-prefix multi-homing. Now, like, today, this works kind of okay if a host support rule 5.5. Not many hosts do support it, but we also don't want to define something that won't even preserve that ability. And so what we say in the draft is that the host must maintain the mapping between the delegated prefix and the router. And we basically say, well, likely the relay is co-located with the router. If it is, then assume that the router, for the purposes of 5.5, assume that the router that gave you that IP address space is the relay from which you got the relay reply. And yeah, why not ICMPv6 redirects? Well, the redirects aren't specific to source addresses. They also scale very badly because they're specific to a particular destination address as well, and it's just very expensive. Next slide. So we really think we're onto something here, and I think it also, like, gives us a glimmer of hope that we can sort of put the DHPV6 versus Slack debate behind us once and for all, and in the process also get this new ability to really have VMs with thousands of addresses on our hosts without causing any scaling problems, right? So we think we're onto something here, and there was some good feedback in V6 Ops early in the week, and we hope that an adoption call will be issued this week. And we also would like, if that happens, we'd also like 6Man to adopt this document if we think there's interest. And I think that's it. Maybe, I guess, next slide.
Yeah, we have
questions.
people in the queue. Suresh?
Hi, Tomek Mrugalski, ISC. A couple comments. So the first one, there's no need for normative language regarding the rebind. That's something that can be forced from the network policy by setting T1 equal to T2, and then the clients will automatically send rebind instead of renew.
I see. That's amazing.
Yeah. So
cool. Thank you.
Second thing, it would be great if this decade-long debate array versus DHCP would be put to end. So
absolutely, we're trying our best. We have an implementation of PD. We just don't do this yet, and this is really hard without changing the kernel. We're going to have some interesting like BPF code mangling the packets and setting like, you know, A to 0 when it sees P equals 1 because we can't change the kernel. But anyway, yeah, we definitely hope that this will solve the problem.
Thank you. Suresh Krishnan. So Lorenzo, I think like I like the draft, like, but the flag you're using is already taken. So I just wanted to point that out. So take the so there's another mobile IP router flag that's taken the flag you want. So like take the next bit.
Oh, we specify a flag number?
No,
Yeah,
no,
you
no.
did. It's a third bit.
My fault, obviously. Yeah, I just took a picture from 46,
Okay.
61 and just copy and paste it. Yes.
Yeah. So the 6275 took the flag. So like
yeah.
take the next
Okay.
one.
Yeah. Missed that. Thank you very much.
Yeah, there's got to be an IANA thing, right? Because otherwise,
Yeah,
if we there's a race condition there.
Yeah.
But yes.
David Nonpadding. I believe there is one, hole or something that this is introducing that wasn't previously there with Slack. If maybe not necessarily in a multi-homing case, but even if a case where an enterprise is replacing one router with another, in Slack, each of those routers can just advertise different prefixes, and you can have a overlapping renumbering kind of with both coexisting. With DHCP-PD, my understanding is that the client will only pick one DHCP server from even if it gets multiple offers from the relay from different routers.
Is it required to do that?
I think so. Tomek, maybe? No?
Tomek says no. If Tomek says no.
Okay, then, okay. I retract my comment.
Bear in mind, like at least for this will be a new implementation, but this is definitely definitely, even if we go back to the multi-homing slide, that's critical for that to work. Yeah. So we definitely need to make sure this does work. Yeah. Okay. Yeah. And of course, like actually one thing that people are, I don't know if Tim is standing up to say this, but you know, we obviously are going to run this past DHC because I'm not a great expert in DHCP, as you can imagine, but I mean, there's some technical issues. One actually weakness here that's not mentioned in the slide is the process of like, how do you do state sharing between multiple relays? The draft in v6 up says don't do rapid commit so that both relays at least see the request. But I don't know if relays plumb routes into their fibs when they see the request. Maybe they only do that when they see the ACK, in which case we'll have to use requery. I think that's out of scope for this draft, but it's sort of required to make this industrial strength. Anyway, so yeah, we'll send this past. We'll run this past DHC for sure. Tim?
Fernanda.
Oh, Fernanda. Oh, go ahead.
Hi, Lorenzo. Some of these comments I might have done on the, when you did the presentation on basics up. So my apologies if, I've just forgot and I'm, repeating them. So I believe that there are some things, some details that, might need to be fleshed out. Like, for example, my expectation is, let's say that there's a, host that would normally do DHCP now. What if, for example, there's a PIO with this bit set, whatever the bit is, but also like, manage configuration. Like I have, for example, a device at home that when you have both bits set, it will do, it will configure addresses via Slack, plus it will configure addresses via DHCP. So I believe that, the way in which the whole thing would interact, with, okay, you can do Slack, you can do DHCP, and you can also do like, prefix delegation would be great, to have it clear what's the path in there. Or if, for example, if the local router is supporting this, but the host doesn't support what's supposed to be the, the fallback, plan. I don't have a preference myself, but I believe that a clear path in that respect is better than, you just connect devices and have no clue what's going to be the outcome, which I have, like, it's already the case with DHCP and Slack. I just don't want to have like yet one more option in which things could go in like different ways. And the other thing is that when it comes to the, the way the prefixes are assigned, that might require some work. I'm not saying it's not doable. I'm just saying that, some details would probably need to be specified because, for example, you could get into situations depending on how you assign the prefixes that might trigger renumbering events, like the same problems that we were discussing before. So you might want to have like a way to the same prefix be reassigned like all the time. Consider the case where you have a local router that just granted some prefixes, it reboots, loses a state, and so on. So you get the same problem that we already get for Slack and and DHCP, with a case that here it would be like prefix delegation. So it's like the renumbering problem would happen within the host. So I believe that that's another thing that should be thought about.
Yeah, I agree. I mean, I think that the renumbering thing is, I think already mostly taken care of by the suggestion of doing a rebind whenever something relevant changes for you. And DHCP is a pull protocol, unlike Slack. So and the interaction with IANA is, I can't think, probably already implicitly defined, because, or maybe we need a little bit of text. But if you do IANA, then you can what you would have to do is have to start asking for PD, and I think you basically have to do a renew with another IAPD option in your ORO. But that also could. I'm not sure if that belongs really in this working group though. So okay, Tim shakes his head. So is this at the level where we need a DHC draft as well, or yes, we do? Okay, Tim's saying yes. All right. Well, okay.
I would like to quick comment on Fernando's comment about renumbering. Actually, this should behave better because we expect host to track prefixes. And when it sees different prefixes, it should try to refresh the information. So it actually covers part of the problem in Fernando's draft.
Yeah, that's true. Yeah.
The other thing is the expectation that is like, if now you're assigning prefixes to hosts, I'm not saying that what we had was super good or even good, but it does change the assumption that now it's like, at the end of the day, the host is identified by a prefix. So no matter what you do inside, now it's like, privacy addresses, for example, temporary addresses, if you want, like now they have different semantics. Again, I'm not saying it's a killer. I'm just saying that the considerations change there.
That is in the V6 ops draft, right? I think the fact that, like the privacy implications, for example, yes, are in there. Yes. But I mean, remember, part of this is to like try to find some compromise with the folks that say IANA is the only way to assign addresses, right? And that is basically what those folks want. They want the thing to be essentially assigned by the network and to change only when the DHCP server says it changes. And that's kind of what we have to do here too, right? So, yeah.
Okay, so let's go to the next question in the queue. Tim?
Yeah, Tim Winters, QA Cafe. One thing I'd say here too is you're going to have to specify what to do with the L flag. You don't want the P and the L flag set at the same time. They're going to think everything's on link.
Oh yeah. That's a great point. Yeah,
it'll be chaos.
Yeah, that's true.
That's my only thing, and then most of it you covered. I think there should be a separate DHCP draft. I'm not sure we actually need to do anything. I have to think about this. I think some of it, 8415 might just work out of the box for all of this, but I think we should go over it again before
I think it does. It's allowed to rebind, but I mean, I think if we find that the client is actually complicated and interesting in terms of what it needs to do, then, like, for example, when do you issue confirms, right?
I think some of this is really just, if you want more information, how you go about asking for it. It's not explicitly laid out in 8415, and I think that might be the thing we have to write a draft about. So think about that.
Okay.
Suresh, so I'll just make it like really quick. So I think I was just triggered by something Fernando said, right? So the M and O bits are short, right? Like, so the meanings of them are like kind of fuzzy, and we decided to keep them that way. So I think having a new bit is the right way to go, because it's not clear what the client does with M bit set, O bit not set, and vice versa. So like, just make sure the semantics of what the client is expected to do with this bit clear, which is to start IAPD, right? Because the M is managed address or a configuration, like we had this discussions today. So just like make sure start from a clean
It really is very clear, I think. In the draft, it's actually borderline overspecified. It says when you see one of these show up, then you start PD, and when you see any of them change, then you kick the PD process. You do a refresh.
Exactly, that's what I'm saying. So like, make sure like, like
the M and the O bits, like, I can feel the ghost of Wule behind me saying like, I will kick you if you touch them.
Exactly. Yeah. Thanks. Thank you.
Tom, you want to make a quick comment, or you're not going? Okay. Thank you, Lorenzo.
Thank you.
Exactly 5 minutes.
Hello everyone, I'm Tony from China Telecom. I will do a summary of the generalized IP6 tunnel GIP6 set meeting at IETF. There are the presenters of yesterday's set meeting. If you have any questions or comments, you can send emails to us. Here's the GitHub link. You can get the information of our work and the slides. Next slide, please. There is the background. Currently, there are many types of IP tunnels. This page shows many tunnels in this page, such as VXLAN and GRE. On IPv6 network, it is hard to define extensions for all these tunnels to support new features. There are also some drafts of the extension of the IPv6 header to support the new features. On the other hand, it is not recommended to extend new features based on IPv4 data plan for these tunnels. Next slide, please. If the existing IP tunnels need to support new features such as IOM, resource isolation, and APN, and the following problems exist. The first one is a lot of standardization network work will be done. All of the IP tunnels mentioned above need to be attended accordingly, resulting in a lot of standardization network. The second problem is a function IPv6 can directly support some functions of these IP tunnels, which cannot be done over the IPv4. This means such functions become redundant over IPv6. For example, VXLAN takes use of UDP to support ECMP. However, the IPv6 VXLAN, the flow label in the IPv6 header can also be used to support ECMP. The third challenge is that it is difficult to extend based on the existing format. Some IP tunnels such as VXLAN and GRE has their own headers. If these tunnels need to support new features on IPv6, they will face the challenge of the choice between reusing the existing IPv6 encapsulations for these new features based on the IPv6 extension header and define new extensions based on their own tunnel headers. Next slide, please. Yesterday, more than 40 experts participated in the SAT meeting. We discussed 3 use cases in data center network and list LAN. Some primarily thoughts about the solution is proposed as well. During the meeting, we mainly discussed the following questions. The first one is the relationship between GIP6 and Geneva. The second is the consideration on whether to extend existing IP tunnels to support new functionalities based on IPv4. The third one is whether it makes sense for GIP6 to support MPLS. The last one is whether GIP6 is necessary is SRv6 is deployed into campus and data center network. In yesterday's meeting, the participants have consensus on the use cases, but the solutions should be discussed. So comments and suggestions are welcome. That's all. The last page of the slides shows the questions should be discussed further. Any comments are welcome. Thank you.
Okay, thank you very much. I think we a bit run out of time for the discussion. So thank you for keeping us informed about your side meeting. So I think this concludes the meeting. Thank you very much for everyone who participated. If you said anything in the mic, please check the meeting notes and contribute to make sure it was captured correctly. Thanks again, Darren, for doing this hard job. Thank you. See you in San Francisco.
Yes, the city by the bay.
What's your plan for Friday? Let me double check, but I think